In this lesson, we will be looking at graphing linear functions and then finding its reciprocal function and graphing that. So the blue line that you see is a linear function. In fact, it's the function f of x equals x minus 3. Obviously has a y-intercept of negative 3 and a slope of 1, so you'll go up 1, right 1, up 1, right 1, or down 1, left 1, down 1, left 1. I'm not worried that you can graph that. Okay, then what we want to do is we want to find the reciprocal of that function. Of course, this is over 1 right now. And to find the reciprocal of something, you flip the top and the bottom. So if I flip the top and the bottom, it would become 1 over x minus 3. That then becomes a rational function because you have a variable in the denominator. Okay? And that variable in the denominator is going to create an asymptote, or a spot where that graph is undefined. And if you think about setting that denominator equal to 0, x minus 3 equals 0, it would be 3. That makes that denominator have a quantity of 0, which of course is illegal. So you will have a vertical asymptote at x equals 3. Okay, then we're going to use our calculators to kind of help us get us at least a somewhat accurate graph of this rational function. So I am going to go up to y equals. I am going to put in the quantity, or 1 divided by the quantity, x minus 3, excuse me here. Alright, sorry about that announcement. Anyways, I put that rational function in and I hit graph, and this is what it looks like. You can see the vertical asymptote at x equals 3. It also looks like it has a horizontal asymptote at 0, but we're going to use our table to kind of help us figure that out. So if I go to my table, you can see the error at 3, so there's your vertical asymptote. And if you were to scroll in either direction and look at what's happening to your y values are getting smaller and smaller and smaller. They're getting closer and closer to 0. They never reach 0, but they are getting closer and closer to 0. And so that will help you think about your horizontal asymptotes. Okay? So I'm going to draw my horizontal asymptote at 0 in really quickly. And then I'm going to use my calculator to help me just kind of roughly sketch some points. So I'm going to plot that point that it's where it's at, 1 and negative 0.5, and then I'm going to plot 2 and negative 1. So 1 and negative 0.5 and 2 and negative 1 is right here, and that's going to give me just enough to sketch that branch of the rational function right there. Okay, and then I will go back to my calculator because I need the other branch. So I need to plot 4, 1 and 5.5. So 4, 1 and 5.5 is right there. Okay, and that will do it. Then on your notes is some spots for domain and range. So I've listed your domain and range here. Notice I wrote that set notation in 2 different ways, and you can pick whichever way you want to write it is fine. Yesterday in the lesson I wrote the top version of it for set notation, but either way is fine, and you might see it written that way in the book or whatever. They mean the same thing. Okay, so that is how that goes. All right, one more. This is another linear function here, and has a y-intercept of 4, a slope of negative 2, so you can go down 2, right 1, down 2, right 1. So that's what that is. That's what the blue line is already. And then if you find the reciprocal, of course, it's over 1 right now. And if you find the reciprocal, you will flip top and bottom. So I will be right here. And again, it's a rational function because you have a variable in the denominator. You need to remember that the denominator cannot be 0. So if I take 2x plus 4 and set that equal to 0 and then solve it, I will have negative 2x equals negative 2. So negative 4, sorry, I'm a step ahead of myself. And then x equals 2. Okay? So when I plug 2 in for x, that makes my denominator be 0, which is not okay. And so that means you will have a vertical asymptote at 2. So you can get that algebraically. You can also get it on your calculator by looking at your graph or your table, which we will do right here. So I will plot the point, or the function, y divided by the quantity, negative 2x plus 4. Hit graph, And of course you can see that vertical asymptote at 2. And then you can also see a horizontal asymptote at 0. If you go and you look at your table, your points will be getting closer and closer to 0, but never touching 0. So you have a horizontal asymptote at 0 here. And then I will get some specific points to plot from my calculator here. So I will go to my table. And I'm going to get just a couple points on either side of that asymptote. So I'm going to plot 0.5 and 1.5. So 0.5, sorry, I think I messed that up. What was it? 0.25 and 1.5. 0.25 and 1.5. Okay, and so just kind of sketch them in, and we can go from there. Okay, and then we'll get one on the other side. So 3 and negative 0.5 and 4 and negative 2.5. 3 and negative 0.5 and 4 and negative 2.5 would look something like that. Okay. All right, I am going to skip that one. By the way, on your previous one, I'm not going to take the time to give you the domains and ranges. If you want to check those in class, that's fine. If you don't want to write them here, that's fine. If you want to try it and then check them, I've got that too. But I'm not going to take the time in this lesson to go through that, with the exception of the first problem, okay? All right, here's another linear function. Crosses the y-axis at -1, has a slope of 1/2, so you'll go up 1, right 2, or down 1, left 2, which is the blue line, of course. Right now, again, this is over 1. When you flip it, it's not going to be very pretty, and I'm going to expect you to simplify it a little bit to make it look a little prettier, okay? So if we flip this, we will have 1 over 1/2 x minus 1. And by the way, that 1/2 x is the same as x over 2, which will just make us think about this a little bit better, because 1x, 1 times x is 1x, 1/2 x is the same as that. Okay, so right now this is over 1. I need to get a common denominator down here, so I need to change this to 2 over 2. And when I do that, I will have 1 over, right here, I will have x minus 2, and then down here is your common denominator, which is 2. Okay, and then instead of taking 1 and dividing by this fraction right here, I can take that 1 and multiply by that fraction's reciprocal instead. So I'm going to cross that off and multiply by the reciprocal instead. Okay, and then across the top I will just have 2, and across the bottom I will have that x minus 2 that's left down there. So the reciprocal function here would be 2 over x minus 2. Again, it's a rational function because it has a variable in the denominator. The value of x that makes that denominator would be 0 is 2. So I know it has a vertical asymptote at 2. Okay, and I will go to my calculator and plot this. So I go to my y equals, I clear this out, 2 divided by parentheses, and I miss my divide key in there. And I'll have x minus 2. Okay, hit graph. And so I have my vertical asymptote at 2. You can see you have a horizontal asymptote at 0 as well. So I will plot that in there. Okay, and then I'm going to get a couple points to plot here. And so when I do that, I'm going to use my table. And I will plot the point 0, -1, and 1, -2. 0, -1, and 1, -2, and kind of sketch that in there. So I've got at least a couple points. And then let's graph 3, 2, and 4, 1. So 3, 2, and 4, 1. And that would look something like that.